Chapter 9, 911, the area of a triangle. We already know that the formula for the area of a triangle is a half the base times the height. But there is also a trigonometric formula if we know the length of the two sides of the triangle and the size of the included angle between them. The area of a triangle. The area of a triangle is a half AB sine C, where C is the included angle between sides A and B. Okay, let's not be confused with that A. That's an A, that's the angle A, but this is the area A here. So the area of a triangle is a half AB sine C. If you want to find the area of that triangle, it's a half of that times the sine of that angle will give you the whole area of that triangle. Okay, so that A there is area. That C is actually that angle C there. And there's a simple proof here. We construct any triangle. Again, that's any triangle. That's not a right angle there. And we label it up. We've got a right angle triangle here on the left. We've got a right angle triangle on the right through the algebra with a common H. And also the relationship between this sine of C is H on B. Another substitution there. We come up with area equals a half AB sine C of that triangle. Example 24. Find correct to one decimal place the area of this triangle. Well, it's got everything we need. We've got an included angle between these two sides, which we also know the lengths of. So we can do this one. The formula, area equals a half AB sine C. So that's our C, A and B. A half, 5.7 times 9 times the sine of 83. It's said to one decimal place, so they've got 25.5. Exercise 911, the area of a triangle. 1. Find correct to one decimal place the area of each triangle. Well, the formula is a half AB sine C, so as long as we've got the angle in between two sides that we know, we can find the area of each triangle. So that we can. We've got that, so we can. Yes, we can do that one because that's an included angle between those two sides. Here is going to be interesting because we need to know that angle. Because remember, we have to know the two sides and the included angle. And the way we find that, of course, is 180 minus that will give us that. Here, we have to do the same as that one there. It's got to be the included angle. So we know that length and that length, so we have to really use that angle. So it's going to be 180 minus that, and we have to use that angle. And here is the same. We need that angle because we've got that side and we've got that side. Question 2, calculate correct to one decimal place the area of each shape. All measurements are in meters. Equilateral triangle, it's got 3 equal length sides and also it has 3 equal angles. So those angles are 60 degrees. So since we know that's 15 and that's 15, we just put the 60 in here. So it's a half 15 times 15 sine of 60. B, parallelogram. We've got everything we need here. We have an included angle between that side and that side. So we find the area of that triangle, and then because it's a parallelogram, that's identical size, so we just double it. C, a kite. We can do the same with the kite. They're equal, so that 100 is the same as that over there. So it's going to be a half, 10 times 25, sine 100, and then times 2, because we've got 2 of them, and that'll give us the area. D, a quadrilateral. Well, we can do it in steps. We'll do this one first. It's a half the base times the height, so we can find that. That's just a regular triangle. Then we can use Pythagoras to find the hypotenuse. That's going to be the square root of 7 squared plus 24 squared is that length. Once you find that length, you've got that length and the included angle, so you can use the sine rule to find the area of that, and then you add it to what we had for that triangle. E, a regular hexagon. Well, this is a whole bunch of those. It's an equilateral triangles. 1, 2, 3, 4, 5, 6. So what we need to do, we know that these angles within an equilateral triangle, just like number A, is 60 degrees. So we know that's 6 and that's 6. So we find one of them, the area of one of them, which will be a half of 6 times 6 and then sine of 60. And then whatever you get as an answer, you multiply it by 6 because we've got 6 of them. F is a regular pentagon inscribed in a circle of radius 8. So we still want to find the area of the pentagon. This is a regular pentagon, so therefore we know that the internal angles are all the same, and we use a formula for that. It's n minus 2 times 180, where n is the number of sides, which we can use for any polygon. For example, a triangle has 3 sides, so that's 3 minus 2 is 1 times 180. The internal angles add up to 180. The square has 4 sides, so that's 4 minus 2 is 2 times 180 is 360. So in this case, we've got 5 sides, So 5 minus 2 is 3, times 180 is 540. And then there's 5 of them. It's a regular one. So we've got 1, 2, 3, 4, 5. 540 divided by 5 comes up to 108. So we know that each of these angles are 108. So if that's all 108, then that one there, the triangle one, is going to be 54. Because it's an isosceles triangle, that's also 54. So together they add up to 108. If they add up to 108, then this must be 72. So we can use the formula now because we have an included angle. So it's going to be half of 8 times the sine of 72. And once we get that answer, we multiply it by 5 because we've got 5 of them. Question 3. The diagram shows the results of a radial survey of a block of land. All distances are in meters. A. Use the cosine rule to find the lengths AB, BC, CD, and AD, and hence find the perimeter of the block of land to the nearest meter. Okay, we have enough information to do that. We have included angles and we've got the lengths. B. Use the area formula to find the area of each triangle and hence calculate the area of the block of land to the nearest meters squared. So the first step is to find these lengths to find the perimeter. They just want to find the perimeter. So you find that one, that one, that one, and that one, add them all up, and that's the answer for that. And the next step is to find the area. Well, we can do that just using these numbers and with the included angles. 4. The results of a radial survey are shown in the diagram. All measurements are in meters. A. Find the size of angle XOY. So that's that angle there. Okay, well, this is similar to bearings in a sense because that's the north, so that's 30 degrees, so we know that's 30. We know that if we come all the way around to here, it's 160. And if we go all the way around to here, it's 260. So it's all taken from the north. So if that's 30 and all the way to here is 160, then this must be 130. So that'll be 130. Okay, so knowing that angle now, the part B is fairly straightforward. Calculate correct to 2 decimal places the area of XOY, that triangle, XOY. So we know that length, we know this length, and we know the included angle. So it's just going to be a half 50 times 40 times the sine of 130. Number 5, O is the center of a circle of radius 20 centimeters. Calculate correct to 1 decimal place the area of sector OPQ. Okay, so we know how to find that. This is back to grade 8 maths. The sector OPQ is that. All right. Well, that's 120 degrees. That's a third of the area of everything. So if we know that the radius is 20, and the whole thing would be pi r squared, which would be pi times 20 squared, and it's only 120 degrees, so it's a third of that. So it's 1/3 times pi times 20 squared. Should give us the area of that sector. B, the triangle OPQ. Well, we can do that using our area of a triangle formula that we just learned. So that's 120, and that's the included angle between that 20 and that 20. So it's a half times 20 times 20 times sine of 120, and that will give us that. So then it says C, the shaded segment. Well, the shaded segment is clearly the sector minus the triangle area. So it's going to be that area that we found there minus the triangle area is going to give us the shaded area. 6, a triangular prism has base edges of 8 centimeters, 10 centimeters, and 15 centimeters, and a height of 20 centimeters. A, calculate the size of the angle PRQ correct to the nearest degree. Well, what a great question this is. That 15, 8, and 10 is the same here. That's going to be 15, that's 8, and that's 10 because it's a prism. We have to find that angle here. We're going to use the cosine rule. And you can use the cosine rule to find angles. All right, so you find that angle. Once you find that angle, you can do B because B says find the area of PQR. Okay, to find the area, once we know that, it's an included angle between 8 and 10. So we can use the sine rule, which will be a half times 8 times 10 times the sine of that angle. And of course, the volume of the prism, number C, is that area times the height times 20 will give you that answer.